privilege of having a working hand.
No.
But, well, some people don't. And that's why we created this robotic hand called Cantaloupe for people with not working hands who have the privilege of having a working hand. Our team is called Team Fingies. It consists of me, Yurgenhat,
Me, Katir,
and the mentors that are helping us.
What?
And okay, let's proceed.
Okay, alright, so our main objectives are to be able to model and design 3 mechanical robot fingers, which we did, as well as the gloves mechanism in Shaper 3D. And next is to be able to write C in Arduino IDE, and also to be able to integrate electronics into the robot fingers mechanism, as well as into the gloves mechanism, which we all did. Yippee. Thanks.
So this is our reference work. We weren't the first one to make this robotic hand, so we took great inspiration from the design of this person. And these are the reviews of the YouTube video in which this person made a robotic hand. Thanks.
And these are the materials used. We had 2 Arduino Uno, 3 servos, 3 potentiometers, 1 jumper wire, breadboard, power supply, and the non-electronic ones are the glove, thread, 3D printed parts, and the tin can, which our fingers rest on. Thanks.
Okay, so these are our 3D model. First, we started designing the fingers, the parts of the fingers, and then we had to find the base, right? So we designed the base. The first rendition of this base is right here, and then we progress to here, and here as we try to set the orientation of the fingers. And then this is the glove mechanism to make the finger move on the other hand. This was the first design, but then later we cut this in half since we decided to use a rubber band. We didn't need this anymore. And this is the spool for the servo, since we need a place for the servo to be able to tie something into. Next.
And this is what this is the modeling plan we did, which is doing the individual finger pieces first, which PK did, my groupmate. There were 2 versions of the finger pieces for this design, and they both had to be assembled by hand. The second part is the finger stand, and it was necessary to hold all the mechanics of the fingers and keep the fingers at the predetermined angle we wanted it to be in. Next was the spool, which, as PK said, was needed to tie the string from the servo, allowing the fingers to move. And lastly was the glove mechanism, which is the thing we use the rubber band on that PK also explained last slide. Next.
So this is our block diagram. So let me explain this block diagram. First, it starts, and then there's potentiometer connected to the human hand. And when we move the human hand, the potentiometer maps the input according to the finger's movement. And then the mapping of the potentiometer gets translated into inputs for the servo. And then the mapping of the potentiometer then gets transferred to the Arduino. Then this is just defining that servos are connected to the robot finger. And then the servos move the robot fingers according to the potentiometer mapping. Next. And this is our code. So this 3 line right here, and then defines the servos, and then these defines the potentiometer and their pins and the values too. In void setup, these 3 lines basically attach 3 of the servos to 3 of the pins on the Arduino board. Next, please. And in void loop, this value 1 is defined at analog read. So potentiometer, it basically says potentiometer 1 will read value from value 1. And then once it reads, value 1 will get mapped into these values. It will get mapped in 180 degrees. And this part is basically, we determine the speed. The more we divide, the faster the finger will move. And then after it gets translated into the value, the servo then writes the value of 1. And these are just copy and paste for all 3 fingers.
And this is the initial testings of the finger. If you click on it, it'll be videos. You don't have to watch all of them.
You're on it. Nerd.
Okay, it's your drive. It's fine, we can just look
We
at
can just change the link later.
Yeah,
Okay.
we'll change the link later when we share the presentation. just look at the thumbnails for now, which is this is the first one with the, can't really see it, but that's the initial finger piece. That's the first model, and this one is the, well, is this the one?
So this one is like the full one where we
Yeah.
also test the servo and the potential.
But as you can see, we don't have the springs on the outside. We changed it for a rubber band because that's easier and less resistance. And this is the final testing which we did today. This is it holding the ball. In the video, you'll see it holding the ball and doing normal finger things.
Alright, so in conclusion, the result is very satisfactory. We learned how to 3D model, we learned how to make flowchart, and we also learned how to code in C and Python. As for the problems, sometimes the fingers twitches too much, sometimes it doesn't behave like we want it to behave. And the solution to that would be to solder the wires and maybe change the speed of the finger a bit. As for the base, the first rendition, it was insufficient, so we 3D modeled a new one.
But we couldn't print it because
Yeah, we 3D printed.
we couldn't 3D print it because it'll take too much time and also a lot of filament. Okay, next. Demonstration.
So,
Okay, can we
demonstration.
move the camera over there some so we can see from the side?
Then facing from that side or from here is fine.
I don't know.
So far good. That's on in. Better?
Okay. Oh, it's disconnected, sorry. Yeah, as you can see, this is one of the main problems with it. It disconnects all this stuff. So, basic motor skills, sorry, my hand's really weird. Basic motor skills, all the fingers can go down. All the fingers can go down, like that. It can also grab a foam ball. It's not that heavy. Yeah. And that's its basic use. Yes, that's.
but basically, as you can see, it completes our main objective, which is for the robot hand to replicate the movement of the other hand.
Yes.
So the original objective gets completed.
And it can also do poses, like a peace sign. That's basically it. And then if we go back to the presentation, it'll be our last slide. Oh. Okay, so this is our last slide, which is a thanks to the mentors who helped us create the fingers, which they're over there behind the camera, and also Kitty Lab for allowing us to have these mechanical stuff, whatever, and also Economic International School for doing this internship with them in the first place. And here's the quote we chose: "When you have a dream, you've got to grab it and never let go," by Carol Burnett. Yeah, done.
Huh?
Watching videos.
No.
Do you have any questions, Zach?
Thank you very much for your presentation. What I see from the presentation, I have some comments. I see that your slide is good. You make it like quite clear, and you can see that you put a lot of effort to do this slide. You also give some reference work, which is always a good thing to do when we refer to some projects. We should refer to some projects that you have referred to, give credit to them. So it's a good thing. And your presentation is good also because it shows that you and your partner has prepared for this well. You also have flow chart, but your flow chart is seen to be, I think it's not wrong, but not only in the flow chart, we should have something like the place where is the diamond shape.
We have that in the report.
Yeah, and in the report is a more detailed version of the flowchart.
Okay, that one is the short version, right? Okay, yeah. So because I just see the diamond flowchart and like for not only the flowchart, we want to see that kind of the decision where it decide to go yes or no, that kind of part. Okay, but you have add in the report, right? Okay. Okay, can you turn to the servo code, your code? Okay, yeah. Can I just ask, can you put up online 2021, 22?
What?
Just ask, yeah. Why you use number 9, 10, 11?
Oh, it's just, we can use any number, we just pick these. It's on the pin, the digital pin.
But why?
Why? Well, it's close together and
Our favorite numbers.
it's our favorite numbers. And they're also numbers of the digital pin, and there isn't really that much number. We just pick these because it's close together and it's easier to connect that way.
There's a reason.
It have this sign in front of the
Look at the
number.
board and look at what the squiggly line means.
It means digital pin.
No, it's not. It's not normal digital.
It's specific.
It have.
Oh, it's PW something, right? Yeah, but I forgot the name. It's like it starts with PW.
PWM.
PWM. Yeah, we use PWM pins because those pins work with the servos. Yeah.
Yes, okay. So it is important for us when you want to control the servo motors, you need to use some specific pin. So I think when you look at Arduino board, right? So number 9, 10, 11, you can see there are some signals in front of the board. So there are six pins to be used for the motors. 3, 5, 6, 9, 10, 11.
Huh, what?
3, 5, 6, 9, 10, 11.
Yes.
Those are the pins.
It's pin for PWM.
So why did we pick these?
Yeah.
Well, we already explained it. Shush.
Oh,
But he's explaining like what
sorry,
other pins you can
my
use.
bad.
Okay, it's okay. I think maybe it's like from the first day we maybe our teacher say and then maybe like since you just use it right and then you just maybe forget about what it is. But it's okay. At least now you know that okay, it's a PWM. Okay. In the testing, I cannot see your testing, right? Just now it's cannot share, right?
Not here on that thing is not a video here.
Oh,
But he got shared later and that link.
oh, okay. Yeah, we actually I want to see in the link is because I want to see how is the demonstration ID. Because sometimes students want to show demonstration, right? They focus